In this video, we're going to dive in looking at a paired or dependent sample and focusing on its confidence interval. But before doing that, we're going to discuss what we're going to do with paired data first. So when it comes to paired data, I don't truly care about the actual values from each population. What I really want to know is the difference between those two values. So this is just giving you some notation. So suppose that xi1 and xi2 have something in common with respect to how this sample was obtained. So 1 and 2 would just be saying which group I'm taking them from, and I would be sort of which pair I'm taking them from. We're going to then let di be the difference between these two values. So xi1 minus xi2. So that's going to be the difference between those two. So really, I'm just going to calculate this difference. Let's take that in context with an example to understand that a bit better. So suppose we were doing our Kroger and Walmart price comparison example, and I decided that I was going to do my order of subtraction as Kroger minus Walmart. Now truly, it does not matter which order I subtract them in, but I need to know what order I subtracted them in, because that's going to give me some important information. Because 3 different kinds of numbers can happen when I do this that all tell me something important. I can get a positive number, I can get a negative number, or I can get 0. And each of those things is going to tell me something important. So if I do Kroger minus Walmart and get a positive number, that's going to tell me then that the first value was bigger. Or in context then, that item's price at Kroger was higher or more expensive than at Walmart. If instead I were to get a negative difference, that would mean my second value was bigger or my first one was smaller, telling me that that item at Kroger then was cheaper than it was at Walmart. And hopefully now you can see also why I'm really just interested in that difference. If I'm going to buy Oreos, I'm going to buy Oreos. What I really want to know is how much more am I going to pay for my Oreos at the one store versus the other. And that's why we calculate this difference. However, if we did get a difference of 0, what that would mean is that the item was the exact same price at both stores. So 0, as you can see here, is going to sort of be a key number for me, because that would mean that there was no difference between Kroger and Walmart prices. We're going to have some slightly different notation to use, because now we're looking at not the prices of the items, but we're looking at the difference in prices of the items. So you remember having the symbol Y bar before, which represented our sample average or our sample mean. What we've added here is this little d subscript to say that's the sample average difference. And so how we would actually calculate that, which I'm not going to initially make you do here, is just that you add up all of those differences and divide by how many of those that you have. And then we also have our standard deviation of the differences. Again, that little d, just to emphasize that it's of the differences that we're finding. N will now represent the number of pairs. So what that means for me is if I were to sample 20 items at Kroger and the same 20 items at Walmart, I'm going to have my N to be 20, because that's my number of pairs or differences that I'm going to be able to calculate. Instead of just mu and sigma, we're going to be using mu d and sigma d, again to emphasize that these are our population average of the difference, as well as the population standard deviation of the differences. So sort of the main thing is you're seeing me add the d subscript on many of these, and a special note that n is now the number of pairs that we have. So what we're going to be doing for a confidence interval then is a confidence interval for that mean difference. So we're going to be going through the same steps that we've done for every confidence interval. Let's first talk through what's different. Well, in step 1, I'm going to have a slightly different symbol that I'm using. Instead of just mu, I'm going to have mu d, which is now going to be the population mean difference of something. In step 2, I have my conditions, which look very similar to what we saw in the previous module. We still have the idea of a random sample, but now more specifically a random dependent sample, because right now, again, we're focusing on paired samples, and it will look different for independent samples. Then we either need the differences to be normally distributed, which we can either assess by looking at a picture or a graph, or by it being stated in the problem for us. If that is not true, then we need a sample of at least 30. And again here, 30 pairs is what we would need. And then finally, as before, our population standard deviation will be unknown, but now is the population standard deviation of the differences. Again, why was this important for me? That's going to tell me that I'm going to be using that t again. So again, as a note, your sample standard deviation of the differences will be known, but because of this, it's going to tell me to use that t distribution. So here is what my new formula looks like. Let's first actually look at our old formula for a confidence interval for a mean. So here's what our formula looks like. If you compare the new one to it, all you'll see is that there's a d subscript on the y bar and a d subscript on the s. Otherwise, it is exactly the same as what you see here. So it's not a huge leap of a difference in a formula. That's why we're doing paired samples first. So the goal in the next video will be to apply doing this math to an example.